I back to the Hamilton method. Distribute the 75 to these 5 counties based on the population. And then we do this. The first, we need to count all the population. So I do this, put an equal sign. The function is sum, which is the sum of all these numbers. Highlight. You cannot click one by one. You have to highlight all so that this is B2 dot, okay, dot, go to B6. You cannot see the comma. If it's a comma, the function will not understand. The computer will not understand. Okay, so therefore, this means total 75 representative need to work with the total population of million people, right? About so that I get this standard divisor. I use the total population divided by this number of representative. So we get 14,000. This means we cut the total population into 75 pieces. Remember yesterday we do like this. If the total population is like a pizza, and then we uniformly cut the pizza into 75 pieces. Okay, so that each representative eat one pizza, right? I think this is easy to understand. So the standard divisor is just the size of each pizza. And then we need to find how many representative here. It's very special here. Highlight. I will do 2 ways, okay? Because yesterday I found some of you students, you cannot use these functions in your system, okay? That does not matter, okay? So I do this way. If someone use a desktop or computer, okay, so that definitely, okay, highlight and then divided by this number, and then Control Shift and Enter. See, so that I get all these directly. And these 3.55 means we need a 3.55 representative to represent this population. Means we need a 3 to 4 slices of pizza, okay, and for the Bristol means like that. But the problem is the decimal, and the human being cannot be decimal. Therefore, we have to round down. Oh no, someone you cannot do this in one time. Let me show another way. If you cannot do this, it does not matter. Okay, so you do one by one. Everyone, you are here. If you cannot do the way as I should, and yesterday I saw someone you cannot do, so that you do this way, one by one. Standard quota. Standard quota means the number of representative. Okay, how many representative we need for each county. So that we use the population divided by the number of representative, the number of standard divisor, and then I get the same, right? And then the second is to do the same way. Use this number divided by this. So I need 11.8 representative, and then the third do the same. It does not matter, okay? You just take a little bit more time, but it's still work. You should, I think everyone's system should be work in this way. Okay, see, I did the same, right? I just do step by step, no matter. If someone you cannot do the first way, please, you definitely can do the second way. And then how to find the number of representative in the yellow step, which is the initial assignment. And the Hamilton, okay, propose this, and just take the decimal away. Okay, so 3.55 representative is impossible. So that I get 3. Okay, do this, get the integer number. But Excel has a function to do that, which is int, integer. Get the integer number of this decimal number. And so you get a 3. I can do copy, okay? So I just move the cursor to the right button, then left hold. Okay, so I can jot down. so that I copy all these box. See, here is the same int, here the same. If somehow you cannot do this in your system, does not matter. Let me show. See, you do the first, right? And then you do the second, one by one. And then you do the third. And then you do the fourth. And then you do the last. Mary's here, let me get it. Do the last. Okay, so therefore we look at it. This is the lower quarter, A or Q. We have a name called the lower quarter. Did the standard something wrong with the decimal, right? So Hamilton proposed to take the decimal away, so lower quarter, so that we get this representative to each county. This is the first apportionment. Make sense so far? If someone you missed the class yesterday, I think the idea is here. That's all, okay? Definitely the method is easy, not difficult. Please keep, okay, so keep listening, don't go away if you did not get the idea. And then, so now we need to go to the second step, extra assignment or extra apportionment or final apportionment. Because we have a total 75 representative, now I only assign 72, right? So that I have a 3 representative. So they are there waiting for apportion, okay, waiting for the apportionment. So how to assign the remaining 3 representative to these 5 county? And the Hamilton proposed, look at the decimal that you take away. See, you take a point, the original is 5.9 to 5. You cut you take 0.9 away from the new part. 0.9 is the biggest decimal number because this is 0.8, this is 0.5, this is 0.6, 0.04. So we should give 1 to new part at the first. So I put the extra sign 1. And then the second largest decimal, which is here, 0.8. So sign the second, and then sign the third. 1, 2, 3 extra or remaining representative should put it to Kent, Newport, and the Providence. They each has 1, okay, representative. So now the final is do this. You just add the initial and the extra together, which is the final assignment. Here nothing means 0, so no worry. So that I can add this box together to put the answer here. Okay, so do this. Put the equal sign, click, type plus, and then click the addition. So I get a 3. I can copy the formula. So I do this. This is a copy. Can you see? Definitely, I finish the Hamilton's apportionment. If for someone you cannot copy, do this. Or you just type whatever. Okay. So you can think about it. 11 plus 1 is very easy. You just type because this is the final already. So 5 plus 1 is 6. 44 plus 1 is 45. Anyone you have a question? No. And then 9 plus 0, which is 9. And can you see it's still the same 75. Make sense, everyone? Okay. And I repeat this part is just for someone you missed the class yesterday. I hope you get the big idea. Okay. If you did not get them, a little bit later, I will repeat another example. Or you catch up after the class. Or please come to class tomorrow. Okay, so I will show you how to do in the classroom. Then now it's Jefferson. Jefferson's idea is another, okay, it's a much more popular. And also Jefferson's method we use the most of the time, okay, we use the many more times than Hamilton's method in the history of the United States. Okay, when we do apportion. So this is the major method. And like Webster just follow Jefferson's idea. And also even Hendon down here, okay, which is the current method, still follow the very beginning, still follow Jefferson's idea. Okay, imagine 300 years, okay, like now what is Jefferson's idea? So first, the yellow step is the same as Hamilton, so no difference. Initial assignment is the same. So let me get this done quickly. Add all the population. Yeah, it's a mulling about it. And they get it, how big is the pizza, right? Each slice, which is the standard divider. Use the total population divided by 75 means cut into 75 pieces. Uniformly cut. We get 14,000 about it. And here the same. I will do just the once. Okay, I save some time. And then Control Shift Enter. And then the lower quarter is the int function. And then copy. So I get a 72. And remember yesterday, I think if some of you in the class or in the classroom, you get it, okay? So the second green step, we call the modified step, right? Or final assignment. And the Jefferson proposed the idea is just recut the pizza, okay? It's not a cut the pizza, assign, and then you sign the second, but a recut. And how to modify the divisor, okay? So how big is the size of each slice? Definitely determine how many representative can eat the pizza. We have a 75 to eat the pizza. If each size, we set at this size, we only have a 72 to eat. Means what? We have another 3 representative no work or no pizza to eat. This means if I cut each size is this, and then we only can cut 72 pieces. Okay, if I ignore the decimal, we only can cut 72 pieces. How many pieces do we need to cut? Exactly 75, right? So that I need to cut smaller for each slice, smaller. Okay, this is too big for each slice. So I cut each slice is too big. Cut smaller. So yesterday we did it, right? Like a 1, 4, 0, 0, whatever. Okay, you do this. And this means each representative only need to work for these people. Or similar, say this number is smaller than that number. I reduce the workload for each representative. Or you say is cut the slice of the pizza smaller than before. Okay, smaller. Therefore, I can cut more pieces. So finally, we increase the pieces from 72 to 75. Is that okay? I do. And then if I modify the divisor, we call the modified divisor. And then follow the same way, okay, as this step. So we can figure out what it is. The same as before. Now, so modify the quota still equal sign. Use the population divided by this number. No longer use the original, okay? So now is the second. Control Shift Enter. If you don't like this, you can do this way, okay? You can do one by one. And how many population divided by this number? And then this population divided by this number, whatever, okay? And then the population divided by this number. And then this number divided by this number. And then the last. Okay, it's the same. You don't need to take more time, a lot of time, okay, just a little bit more. And then here is the same integer function, right? So lower down, see, it's the lower quota in Jacob here. It's the lower quota in Jefferson's method. The same idea as hammer down, okay, to lower down or to round down the number. Okay, I finished the first. If you can do, you just copy. Okay, it's good. Or you cannot do. If you cannot do, you can just type or you copy, whatever is the same. I just repeat, and then until remember you have to use the formula, otherwise a little bit later we will modify it again. You will have trouble. Okay, can you see? And then we also get it right. Or another way to show this. If someone you like it, you can do another. Can you see? Look at this. I highlighted this box, Control C, or copy. Okay, or let me do. Oops. Or up here. You see the right side. So can we copy? Yes, I copy, and then put here. I paste. Don't paste the value. Okay, paste the formula. Can you see? It directly. Okay, this is also another way to copy and then paste, and then paste, and then paste. Okay, so this is also a way. Whatever the way you like, a lot of ways. And now I still cut 72 pieces of the whole pizza is not good, right? But because I use all the boxes formula, and if we change this number, it will automatically change everything in another box. Okay, so I can modify this, and then see, this means standard divisor means the size of each pizza. If you cut this size for each, and then the whole pizza will cut into 72 pieces. But we need to cut it into 75 pieces so that every representative have one piece, okay, to eat, right? Okay, so that we need to cut more. So I have to get this number smaller. Does that make sense? I have to cut a smaller for each slide, smaller for each slide. Okay, so that I cut it smaller. For example, 3, 4, whatever. Okay, so you can see. Oh, I cut it bigger. Okay, see, I get it more 0. So this number is smaller than that number. So therefore, I should cut more pieces of the pizza. Then now I cut 72 pieces. No, I cut 76. But I only need 75, right? Because we only have a 75, means I cut more. So therefore, the size of each slice is too small. I have to get this a little bit bigger. Whatever, you can just bigger try. So go to 5. Yesterday we tried no. And then go to 6. No, see here's the others. And then go to 7. Yeah, this is not good. And also yesterday I showed if I change it to 8. So how do you think? See, still 75 means this number, the modified divisor is not a unique number. So that's the power of Jefferson's method. We just modify the divisor so that we cut the pizza in pieces, recut the pizza. Does this make sense? Let me see. Yesterday, yeah, Fiona, you're not here, right? Mary's not here. Yeah, Finny here. Finny, you get it, right? Okay, you get it. Yeah, Fiona, I know you are here today. I just want you to get the topic because yesterday, some of you, because of the test, you missed the topic, okay? Yeah, Kimberly. Kimberly did not. Yes, I just repeat, so I hope you get a more idea Or please be sure to comment to class if you still did not get the idea. Yeah, Giovanni, good. This is Jefferson. Now let me show you what is Webster. Okay, so everyone, now you have to think only one difference between Webster's method and Jefferson's method. Okay, only one tiny difference. I just want everyone to know what is the difference. Okay, and everything is the same except this function. This is a round down. To get it done, take the decimal away. But Webster's method is just do normal rounding. What is normal rounding? See, 3.5 rounded to 4. 11.8 should be rounded to 12. 5.9 should round to 6. And then 9.04 should be round down to 9. Okay, everyone know the normal rounding. And then, of course, here the final is also use the normal rounding. That's the one we use the in Webster's method. The Webster completely follow Jefferson's idea. Okay, just said, so why you need to round down? We should do normal rounding. That's the reason why. Okay, so in the history, we use Webster's method also multiple times. Okay, imagine. Now let me do one. So here all the same, right? Except here is a new function. Except here new function. So please look at it. And then everything is the same. Okay, so you can just think about what's Jefferson's method. So I get how big the pizza, which is the sum. If someone you like, you can take a note. Okay, because this is just a technology. Just show yourself which step use what kind of function or how to perform. Okay, I know you know how to take notes, right? So everyone know how to take notes. Here is find the sum, and then find how big is each piece. This divide by this. Uniformly cut these into 75 pieces. The problem is the decimal, so therefore here's decimal. Okay, so why we need the second step, and then here the same. I just use I use this way. Okay, I use the old. Okay. And I use this divided by this. I know someone you probably have to use this way. Okay, so I just do this way. We don't need to take more time. Okay, we don't need to take a lot of time at least. Okay, it's a little bit of time. Okay, so see this is the one we get, and then here is something new. Okay, so everyone, so that means this you see is RQ. What is RQ? R is a round quota. This RQ means a round quota. Round means normal rounding, normal round. It's not take the decimal away. Depends how big is the decimal. If the first decimal digit is more than 4, we round up. Otherwise, round down. Okay, that's the normal rounding. We learned from very young. Okay, and then what the function round? You can see round. To find the integer is int. To do normal rounding is round. Okay, just a round and then parentheses. You see 1 input, 2 input. So the first input this number. The second it says digits. How many digit number do you round to? I don't need the digit number. I don't need the decimal number, right? So that I put a 0. Because I will round to an integer number. It's not rounded to 3.5 or 3.6 like that, but rounded to 3 or 4. Okay, so therefore no decimal. This is very special, everyone. You have it, if you want to use, you have to take a note. This 0 means no decimal places, comma 0. And then, see, that's good. This is normal rounding, right? This is normal rounding, okay? So 3.5 to 4. And then copy. Okay, this is a copy. Or let me do this. Another, you just say, you just Control C, and then Control V, Control V, Control V, Control V. Okay, just paste, okay? Copy and paste the formula. Is that okay? So the same way. Or you just repeat the procedure. Okay, you see, so all the same, right? Except here is a round function. And then, anyone think the first assignment is 76? Do we have a 76 representative? No, we don't have. Or it says if you set up this is how big is each slice. If you set up that number, the divisor, and they ignore or do rounding, what do we get? We get a 76. It means I cut the whole pizza into 76 pieces. Okay, we get a 76 pieces. No, it is wrong. We only need the 75 pieces. We cut the pizza into 75, but now I cut 76 means each piece is too big. No, each piece is too small. You cut too small, therefore you cut more, right? So therefore I have to get this piece bigger than before, bigger. I don't know how. My suggestion for you, this is a trial, okay? This is trial and error. Just look at it. I only cut one more piece, so it means I only get this bigger a little bit, right? Because see, 76 to 75 is only a little bit of difference. Therefore, I put the number here should be also a little bit difference from this number. Does that make sense, everyone? Is it get bigger? Your piece is too small, get a bigger, a little bit bigger, okay? A little bit, I don't know, probably I will try this 500, okay? Probably 500 is they are too big. I get 100 or whatever, okay? So let's see. So now it's the same. It's the same. I just do this way. Okay, if somebody like do this divided by this number, okay? And then do this divided by this number. And then the same, this number divided by this number. And then the same. I really don't like to do this one by one, okay? But does not matter if your question is small. But if you do a bigger job, we don't like this, okay? We don't like. Like if we do the apportionment for the whole country, so therefore we have a 50 state. Do you want to copy 50 times? No, no one like that. Okay, so divided by this. This one, and then what the name of the function? Everyone, do you remember the name of the function? Normal rounding. Can you type in the chat box? If someone remember, can you type in the chat box? Yeah, anyone remember? Jonathan, remember what the name of the function? Chris? Fanny, do you remember? INT? Not INT. Not INT. INT integer is a Hamilton and Jefferson's method. But now we do Webster, okay? What is the way? Okay, good. Giovanni says round. Round is correct. Round. Normal rounding. Don't forget round, okay? Normal rounding in Webster's method. So that this. Anyone remember what's the number we have to put at the end? What the number is? 0. Good. Thank you. 0 means what? Means no decimal places we need. We need a 0 decimal. Okay. We need the integer. And then copy. Okay. I just do this copy. Oh, can you see it's good? So I just try once. I get the answer. That makes sense. These are all the methods I want everyone to learn in this class. Okay. We learn Hamilton, Jefferson, and Webster. How to do in apportionment in Excel. Imagine if you want to do a bigger job to distribute the like a 100 or 200 representative to 50 state for the whole country. Yeah, it is almost at the same time, right? Like you can finish your job in 1 minute. Definitely, you can finish it in 1 minute, right? Because no matter it's 5 or 50, you just copy. So all the same way, okay? That's why we learn. That's why we learn the method in Excel. I hope this makes sense. It just kind of a sense for the efficiency of calculation in Excel. Imagine everyone. So that in the future, if you have a chance to try to learn a little bit more for data analysis in Excel, because Excel is much more powerful than a calculator. Okay, no matter what kind of calculator do you have, this one is the most powerful calculator. And then here I just leave. Okay, see, we still modify. So you know what? You know, the current method, apportionment method, still follow Jefferson's idea. So how big the contribution is, okay? The big contribution from Thomas Jefferson. So are you here now? I will ask you some question, okay? And then I know someone probably did not get some detail how to do in Excel. So I still hope, okay, as me, please come to the classroom tomorrow. I will show you again. 1, 2, 3. See, we have a coda rule. Paradox, another paradox, another paradox, okay, to show to you. See here. And this time definitely, okay, I want you to think to answer the question. If you get it, can you type in the chat box? Okay. What's your answer? See the first question. Keep in mind here, we're talking about Hamilton's method first. Hamilton. Remember? Okay. Alexander Hamilton. Hamilton is the first method, okay, in the history. We go here. Which of the following quantity will be obtained if we divide the total population by the total number of representatives when we apportion Congress representatives to different states using Hamilton's method? Yeah. There says standard divisor. Destiny is a standard divisor. Is that a standard divisor? If you think so, or if you don't think so, also type your answer. Finny, Jason, I'll get an A. Fiona, get an A. Yeah, Cameron, get an A. Giovanni, Aurora, Jacob, Savannah. Okay, Jonathan, I think it's, yes, everyone, you get it. Most of you, at least most of you answer the question. Yeah, so definitely I know you are here. You're not go away. Yeah, Kimberly also get an A. Great. A is the correct answer, definitely. This is the definition. How big is each slice of pizza, right? So how big is each slice? Or is here a standard divisor. Okay, standard divisor. Divided, oops, sorry. Just a highlight, okay. Divided the total population by the total number of representatives. That means like the example just we have is 1 million total population divided by 75 total number of representatives. Means what? We just cut the total population in 75 pieces, okay? And each piece, the number, I think you remember, is about 14,000. That 40,000, that the results we call the standard divisor. Somebody forget? See back. This number is the total population divided by this, we get it here. This is the most important, the very important number, okay? The divisor. How big is each slice? Or how many people one representative need to work with, right? How many? 14,000 people. One representative need to work with, work for, whatever. Or need to representative. Okay, so each representative represents the 14,000. Okay, look at it one more now. Think. And the same, I want you think to get the answer of yourself and then type in the chat box, please. Which of the following quantity varies, changes from state to state when we apportion Congress representative to different states using Hamilton's method? Which number changes, or it means which number is different for different states? This means varies, right? Varies, okay, or you say different. How do you think? These are A, Destiny, at the C, Biana, C. Try to type your answer, whatever you think, okay? If you have it, you just type. Then I will show you the correct answer. So Aurora, get C, Jason, we have a lot of get C, right? Yeah. Chris, Anisi, Christina. Oh, get a C. Yeah, good. Most of you get a C. C is the correct answer. Congratulations. The C is correct. Okay, C. And the A is not. Okay. Imagine A is only one total number of 75. Remember the question, 75 representative for all the county in our example. Remember that? And we did. In our example, the total number of representatives is 75. We only have one number of total representative. Yeah, Savannah. Oh, yeah, that's good. See, this number is the same, right? No matter how many states, it's the same. And then what is the difference? Yeah, see, this number different. This is different. This is different. This is different. Why this number definitely different? Imagine. Standard quota never be the same in the history of the United States. Do you know why? Never be the same, because this number is obtained using the population of the state divided by this number. The number of the population in different states always different. We never have this case, okay? Two states have the same population. Do we have in the history? No, never, okay? Never. Because the population different, therefore the standard quota definitely different and varies, changes from state to state. I think this makes sense, right? Yes. Giselle, you get it? Good. Can you think of one more here? Now, which of the following best describe how the standard quota for standard quota? Remember, if it's standard quota, then it's different for different state. How do you get it? In Hamilton's method. A, B, C, or D. How to get a standard quota for one state, for a state? Can you think? Vienna thought B. Jason thought B2. Benny, B. Destiny, B. Hanesi, B. Aurora, B. Giselle, B. Giovanni, Chris. Yeah, good. Thank you. Thank you for your answer. Okay. You are correct. And Jemiah, Savannah. Yeah, great, MD. So all you're correct. Okay, definitely. So divided the state's population by standard divisor. Okay. We don't have modified divisor in Hamilton's method. Okay. So this. And if I look back, how we get this number, use population divided by this. Okay, so we get this. Great. Can you think about this? It should be easy. Try to give me. What's the rounding method in Hamilton? How did the Hamilton round? Round down or round up or normal round or another way? Try to think to get an answer for us. Hamilton, remember, is the very beginning. We did it yesterday, or I did it today at the very beginning. Or the easiest method, okay, you remember Hamilton. Alexander Hamilton. That's all the famous guy in the history. Giselle. Giselle get an A. Round down. Fiona get a B. Round up. Any other answer? Think. Please try to type your answer as quick as you can. Penny, D, none of the above. Aurora, C, normal round. Destin, none of the above. This question looks very hard. A, B, or C, or D. So each one has some of you. But look at the most. We have more D than other answer, right? None of the above. I mean round. Okay. Round means how to round in the number. From the standard quota to the initial apportionment, remember? From the decimal number to the integer number was the way Hamilton's method did. Or let me just show one more time, look back. This is the decimal number, and this is not a decimal number. how we go from a decimal number to not a decimal number, an integer number? How do you think? As a normal rounding? Remember, is this a round down? Round down is go down, get smaller. Round up is get bigger. Normal round sometimes get up, sometimes get down. And this time, okay, so how do you think? Round down or round up or normal round or none of the above? Can you rethink and retype your answer, please? No? No? John, Fiona, round down. Anyone? Do you agree? Round down. Is that a round down? Jonathan, do you think it's a round down? Round down means go down, right? Get a smaller. Fiona, you are right. Okay, you're correct. Thank you. So everyone look at this. This number is lower quota and finish good. Lower quota is get a round down. This number 3.5 go to 3, 11.8 go to 11, 5.9 go to 5. Even this number go to 9 is always a round down. Down means go to a smaller number. Make sense, right? Does that make sense, everyone? So round down is the answer. Okay, the method and Hamilton's method. Round down, lower quota. Remember? Lower, okay, it's just take the decimal away. I want you to think another, okay? So here, this is the question. Which of the following method never leads to violation of the quota rule? You don't know what is quota rule. I did not show you. So now I tell you what is the quota rule, okay? So that's what we call it a golden rule in the history or in the beginning of apportionment. At the very beginning of apportionment, we call it quota rule or the golden rule. This is the golden rule. The quota rule says, everyone, this is something new, okay? So you need to get the idea. The quota rule says that the final number of representatives of a state gets should be within one of the standard state's quota or standard quota. Here, within one of the standard quota. Within one means the distance is no more than one. That means within one, okay? Can you see? That we call the golden rule. Within one, okay, keep in mind. One distance between whatever your final quota and the standard quota. The standard quota is the standard, okay? And then state's quota is the final apportionment. The distance between the final and the standard should be no more than one. Yeah, that's good, right? Do you remember what is standard quota? Standard quota has decimal. If the standard quota is not a decimal, that should be the quota, right? The final quota, because that's definitely true. Okay, based on we count how many pieces and then they take this. At the very beginning, this should be standard. That's why we call it standard. But because of the decimal, because of that trouble, we propose different method. Whatever the method that you have, finally we have to compare the final apportionment with the standard quota. The difference should be no more than 1. This is the quota, and this is the quota rule. Can you look at Hamilton's method? This is the standard. This is the final. Do you think the difference is more than 1? No. Always within 1, less than 1. Why? Because I add the 0, no add, or at most I add 1. So at most I add 1, right? I never put the 2 extra assignment here. That's Hamilton proposed. Because Hamilton's method definitely follow the quota, the quota rule. I hope this makes sense. Or you can look at it, this number 44.6 to 45. The distance, of course, less than 1. 9.04 to 9, less than 1. This is less than 1 or less than 1. We follow the method. How about the Jefferson? No. Jefferson's method not always follow quota rule. Because Jefferson's method is not add extra. Remember? Not add extra, but reassign. If you look at that, you just modify the divisor. No one knows what will happen, okay? Probably will violate the quota rule, definitely in the history. When we use Jefferson's method, some result did not follow the golden rule, okay? Did not follow the golden rule. But Hamilton always follow. Okay, so therefore, here, what do you say? So never lead to violation of the quota rule. And from the knowledge we have, never. The only, okay, so just get it, the answer is Hamilton. Only Hamilton's method. Jefferson's method is modified divider, so I don't have an idea, okay? So what's the difference between the standard quota and the final apportionment, okay? Sometimes the distance is more than 1, sometimes. And Webster follow exactly the idea from Jefferson. So sometimes the Webster method also, okay? So therefore, we have this answer. Make sense, right? So this is one new knowledge called quota rule. Is a golden rule of apportionment at the beginning of apportionment in the United States, okay? It's golden rule. But you know, the Jefferson's method looks very fancy, it's good. So that, okay, so in the future, we don't need to exactly follow the golden rule, okay? Now, here. We will answer this question. Why Hamilton's method follow golden rule, but the Jefferson's method probably will not follow golden rule? Why we will not always use Hamilton's method to do apportionment for the whole country? No, you just check the history. The Hamilton's method we used only a few times in the history, but the Jefferson's method we use a lot of times, okay? We prefer Jefferson's method. We like Jefferson's method much better, more than Hamilton's method because of this reason. See, paradox. Alabama's paradox, New States paradox, the population paradox. The paradox means something we get something wrong if we use Hamilton's method. Hamilton's method causes paradox. Hamilton's method caused the Alabama paradox. Hamilton's method caused New State paradox. And Hamilton's method caused the population paradox, okay? So therefore, Hamilton's method can lead to the following 3, okay? Except, of course, except this. Anyone tell me what's Jefferson's paradox? Do you know what is Jefferson? Now you don't know what is the new state paradox or the Alabama was a population, but you do know what's Jefferson. Do you remember Jefferson's paradox? It's completely different, okay, from our topic, right? The Jefferson's paradox is for the basic data analysis. If you look at the average, we cut the group into parts, or you put the parts together. We learned from this is the topic 1.3 we learned. Does not belong to apportionment, okay? And I want you to learn these 3 paradoxes because that's famous in the history. So you got it. You understand that we have a bigger disadvantage of Hamilton's method. And the first, take a few minutes with me, okay, everyone. Are you still here? Please don't go away. Jason, so everyone here, can you type yes to let me know? Because I did not see some of you. Yeah, good. Good, you're here. It's Aura. Giovanni. Yeah, that's great. I think most of you are here. So let me just introduce. It's very fast, okay? What is Alabama's paradox? Okay, it's in the history of 1880, in the history of the United States. When we do a census and we found that the country grow, the total population grow, and we need more representative, right? The population grow, we need more representative for the whole country. And then we think about this. Before we increase the representative and we compare the results with the previous apportionment, and then we increase the representative. Or for example, is like this. See, if I increase the population, I increase 75 to 80. I increase 75 to 76. I do the same apportionment. What do you think? What's the results should be logic? If I increase 1 representative, should be some state finally increase 1 representative, right? This should be logic, okay? I add the 1 representative, probably I add the 1 representative here, or here, or here, whatever, we have a reason. But what is the history? You can see the situation. I highlighted the words, or you can read. When we increase the number of total representative, Alabama ended up losing a representative in the process. And this is something contradiction. Does that make sense? Okay, so everything is the same. I increase the number of representative for the whole country. Why Alabama will lose representative? Doesn't make no sense, right? Make no sense. The representative increase. Why my representative for the country, for my state, is decreasing? It is not good. Make sense? Everyone make sense? Yeah, this should be right. Increase the number of representative should be. We cannot lose representative. Either keep the same representative or increase the number of representative for my state, but Alabama lose representative. That's the one we call Alabama paradox. It is impossible. Okay, I increase 75. See, this 9 goes to 8. It's impossible, right? It's not good. At least I know this is not good. It's not logical. So Hamilton's method causes something that's not logical. Okay, that we call the paradox. 1. The second, new state. So everyone look at the new state paradox. That's another case in the history when we use Hamilton's apportionment method. See, in 1907, okay, so more than 100 years ago, And then when Oklahoma became a state, joined the United States at that time. So think about that case, okay? And then we have the same representative, no change, the same representative for the whole country. And the original is like a 40 state, and then we have one more state join. What is the result? What is a logical result if I reduce the apportionment? I shouldn't what? Because Oklahoma has a population. So Oklahoma should need some representative. For example, 5 representative. We should, these 5 representatives should come from other country. No, not other country, other states, right? Some, it means if a new state join, and the logical result should be some state lose representative and give that representative to the new state. That should be logical. However, when we use a harmonism method, can you see? But Maine gained a representative from New York, or whatever don't need to see from New York. You just think about these results. How could that possible? We have a new state join, and then we reapportion again. And then Maine, okay, the old state, and then increase the number of representatives. Use the harmonism method. This is not a, is this logical? This is not a logical, right? This is not a logic. Everyone make sense? A new state join, and the many either will not give out the representative or keep the same. Either keep the same number of representative or give out some representative from many to the new state. However, Maine gained get a representative. This is not a logic. So that this is the new state paradox. And the last. But look at the population. We compare the 10 years, the 2 years in the history. One is 1900, another is 1910. Okay, and then these 2 years we use the harmonism method. And we look at what's the result. The total representative, no change. The total number of representative for the whole country keep the same. And for example, 100 representative in this year, 100 representative for the whole country in this year. However, the population changes, right? From state to state. And now we think about it. We compare 2 states. This one is Virginia, okay? And we look at it, the population grow. We look at it, the situation of the population between Virginia and Maine. And can you see is this? Virginia is a much bigger state, everyone knows, and also grow the population much faster and grow more people, definitely, okay? And therefore end up with more people than Maine. So Virginia has more population, and also the population grow much faster than Maine. However, when we do the apportionment in 1910, and Virginia end up losing a representative to Maine. Means Virginia lose a representative, but the Maine gain a representative. This is not a logic. Is that a logic? No. My state is much bigger. My state, the population in my state grow much faster. I should gain, right? I should not lose representative to the small state. Does that make sense? This we call a population. Okay, this we call the population paradox. Think about okay, the logic inside why we call it paradox. And also, I think I have at least one question in the homework in my open math. You have to use this kind of stuff. Okay, so you need to know. The last question, let me redo. Okay, so let me show you. You have a lot of questions, and you have to do apportionment, and in your homework in my open math, like here. So can you do how to do? I will show you how to modify. Okay, so modify our template. So what the template? I just delete. I just delete everything. Can you see? Or we look back at the question. The legislature in a state that has 48 seats apportion these seats to the 5 counties based on the population. Suppose we have a county A, B, C, and D, and each one has a population here. And how to apportion the 48 seats? Similar, right? It's a similar question. And the question's Hamilton's method. Let me quickly do Hamilton's method. So how to do? Make sure. See, I get the templates. I don't need all these data. I need to modify, right? So I need to modify. Okay. I cut all this. I cut all this. Okay. So suppose that makes sense. Now you just change the data and then follow the same step of apportion. And like a state A, county A, B, C, D, E. Okay, so I modify the county. I need to copy the population. So let me copy the population. So 30,000. Yeah. No problem. Giovanni, no problem. So you are here. And then I'll copy. So everyone, this is the way you can finish your homework easily. You just use the template. And then 45,000. Okay. And then the 100,000. One more. 100,000. And then here is 39,000. And then the no, not a 39, sorry. 39,000, right? And then the last 47,000. 1, 2, 3. Okay, so and then I put the number of representative, which is the seats 48. We need to cut into 48 pieces, right? I put 48. Can you see? So that's the same as the original question we did in the class. Okay, so let me do the last one. Okay, we finish this. We stop. Okay, today I get the sum. If someone you forget it, can you see? I do one more time. How to get the sum? This is the way I get the sum. How to get the standard quota? And this the standard divisor. Sorry, divided by this. I cut this population into 48 pieces. Okay, so this one, and then I highlight. You don't need to exactly follow mine. Okay, so I just save time. Control Shift Enter. Okay, and then round down, right? Round down. Okay, lower down, lower quota. So I get these 5 and then copy. Okay. So now Hamilton's method is just assign extra. We have a total 48 seats. Now I already assigned 46. So therefore the difference is 2. I have 2 remaining representative to sign. Sign to where? I look at the decimal 6, the biggest. I put a 1. Then 5, the second biggest, and the 1. Okay, and then I do addition. This number plus this number. Easy. You just do by yourself. Or this is 48. So therefore, I get a 6, 8, 18, 7, and the 9 should be the final apportionment when we're using Hamilton's method. 6, 8, 18, 7, 9. 6, 8, 18, 7, 9. So B is the answer. I just modify. Okay, you just modify the template. Okay, so the same for your questions in my open map. If somebody did not get it the way how to do apportionment, everyone, please come to class tomorrow. And then I will help you, or your classmates will help you to do the portion in Excel. I hope everyone don't miss the topic. Okay, that's a big topic. Thank you. See you tomorrow. Have a good day.